So hello everyone. In this video, I'm gonna teach you I'm gonna just practice with you a exercise on how to study functions. So we are going to start with a typical function that includes the ln. So firstly, we are going to yeah to study this function. We call it. I'm sorry. G of x. Same, it's just a pronunciation. Okay, g of x equals we take it x minus ln x. So firstly we are going to determine the domain. Okay, the domain of definition. So we say yes, definition of g, yeah, domain of g equal, so we will use this technique, x, yes, equivalent to x will be straightforwardly greater than 0, so because it is in the ln, yeah, in the argument, so we are going to check this condition, and we have no other conditions, so the d of g equals to 0 infinity. So good. Now we are going to calculate the limits. The limit of g while x goes to the 0 from the right. So it equals to the limit x close to 0 from the right, 0 plus of x minus ln x. So firstly, we know the limit of ln is minus infinity when the x approaches the 0 plus. So yeah, minus infinity will with the minus will be after plus infinity, and plus 0 it says a plus infinity. Good. Now let's move on to the next limit of x approaching the plus infinity of g of x equals limits of x approaching plus infinity of x minus ln x. It equals, so first of all we have the limit of infinity. Here we have a indeterminate form, so we will need to factorize it with a x to applicate the reference limits. So on x over x, so we have this limit as the course says, it equals to 0. Yes, good. And infinity times 0 times 1, because 0 will go, and we say we have only the 1, and it will be multiplied with plus infinity, and after we will get plus infinity. It's too clear. So now let's move on to the next example. Okay, question 2. It is the table of variations of the variations of g. So first of all we need to calculate the derivative of g prime. So first of all we will see the function. Okay, x minus ln x prime, it equals to 1 minus 1 of x, 1 over x, yes, equals to, good. So we know as the domain is the 0 plus infinity, okay, x of 0 plus infinity, so we are speaking here about a variations, a table. We need to draw a table of variations of our function g prime. This, okay, the sign of the g prime will give us the variation as we know. So this goes to 0 when x equals to 1. Yeah, cool. So 1, we'll take 1, I have a 0 right here, and we'll put a minus here, minus sign, because because we have the number multiplied by x is a positive, it is plus 1. So in the right we put a plus, and we know that. Okay, good. So it will be going down and then up because we have the signs. So if we took the sorry for speaking French, I just forget. Yeah, I'm just trying to use English because it's universal. So let's take the f of the 1, it's 1. Cool. We said the f of 0 plus is plus infinity. Same thing for plus infinity. Yes, I just check. Yeah, it is, as you see here, it is plus infinity and plus infinity. Cool. So we're done. And then we can know the sign actually of g. You know that 1 is a minimal value of g. We can say g of x is what? Is greater or equal to 1 if we took any x of 0 plus infinity. Cool. So we're done of that. Now we go to we will go to the next question that tells us you must demonstrate this. Okay, demonstrate. I'll just write them to refer to the demonstrations. So you must prove that this is the prove that x is greater than ln x whenever x was in R. Okay, that means that x it's the same that saying 0 plus infinity, if you know the yes. So we said that whenever we talk x of if we talk x of 0 1, as you can see in the table here, of 0 1, we have a variation, a constant variation of g. So x of 0 1 will have x is greater it is less than 1, less yes. So what is the monotony of g? It is going down, so it is yes. So we can just compose with g and change the sign. We have the g of 1 equals to 1. If you can see here, we said g of 1 equals to 1. So we are just going to substitute g with 1. So g of x is greater than 1. Cool. If it was greater than 1, that means that it is greater than 0. This is clear. Okay. If it is greater than 0, that means that x minus ln x is greater than 0, and that means that x greater than ln x. if we took any x of this interval. So we are just going to switch the interval to 1 plus infinity. So we can add the 1 here, yes, plus infinity. If we took this interval, we have g is going up, like you can see in the, I don't know the right word that you use to express the movement of up in English, so I'm just going to say it goes up. Okay, so cool. If you know, just tell me in the comments and it will be good. So let's move on. We said that x is greater than 1, that's equivalent to say that g of x is greater than g of 1. We have g of 1 is 1, that means that it's greater than 0, and then we will say that g of x is greater than 0, that equals to x is greater than ln x, and we have the same thing here, as you can see. So whenever we have x of this interval, we will say x is greater than strict, I don't know how you call this sign, but I know that this sign means or equals, greater than or equals to. So cool. You can tell me also what does this sign mean, greater than. Yes, we add a word that I don't know in English. So cool. Now it's greater than ln x. So now we will move to the next question. I will just add a page at the end, so let's move on. Okay, as we said, for the next part we will have a question, a function, a new function that we will use the first function to study it. Okay, let's study this function. F of x equals to the square root of x minus 1 over 2 ln x squared. Okay, good. Now you may need some attention to you know that the domain is 0 plus infinity. Cool. Yeah. Now let's calculate the limits of f of x. Yes, x when x approximates the 0 plus of f of x equals to let's see the limits of x equal appreciating this. Yeah, and I want also to know what we call that when x approxiate the 0. No, we can't say that. You tell me also the right word? Yes, okay, ln of x squared. So here we have the limits of the ln x when x goes to 0 plus, so we have it minus infinity. Good. And this equals to 0, so 0 minus infinity equals to plus infinity, squared is says plus infinity. Cool. So we have plus infinity in the first limit. Let's move on to the next one. When we take a limit of x goes to the plus infinity of f of x equals to the limits while x approxiate the plus infinity. Yes, the plus infinity, we will write the function x minus 1 over 2 ln x squared. Cool. Now the limit of those will make a little bit problem. So it goes, the first one it goes to plus infinity, and the second one plus infinity. Yeah, we have a undefined form. So what we are going to do is to try to applicate our relation that we studied. Like we can factorizate. I don't know how we say it in English, but I think it is factorizate. Yes, to like this, x squared minus x, we do this is called a factorization, I think. I don't know, like this in English. Okay, cool. Yeah, you can check me all those vocabularies so I can remember them. Cool. Now let's move on. We have yeah, we can factorizate with a with x. So x factorizate of 1 over c of over I'm sorry, I spoke again in French, over square root x of x. Oh, so what we do here is we subtract, we divide by the x. Is ln x over x. Cool. All of this squared. So what we have here, this goes to 0. This also goes to 0. And this, where is the problem? So we will still have a indeterminate form. So in this case we are going to use a other method to do it. It's too easy. If you can see a important thing in this. So first of all, the limit of x when it goes to the plus infinity of, okay, if you can see here, we have, if we factorize with x, so we will still have here a 1 minus, look 1 minus 1 over 2 over of x ln x. How did I do that? We have here a square. Let's t equals to square root x. That means that x equals to t squared. Now it becomes, when x goes to plus infinity, we have t also goes to plus infinity. How we know it? If we substitute here x with infinity, we have t equals to infinity. To the square root of infinity, it equals to infinity. So just we are seeing that, but we cannot write it. So we write the limit of t goes for infinity plus infinity of t squared, because we substituting the x with t squared, factor of 1 minus 1 over 2 of the ln of t squared over t. So squared, we don't forget the square. Then we will get rid of the 2 that we see here, the 2, so we will get it to the denominator. So the limit of t when goes to plus infinity of t squared, factor of 1 minus the 2 will come and will be simplified with the other 2, and then we will have ln of t over t squared. So in the last of this we will get a plus infinity, because when we have the ln of an x over an x, when x goes to infinity it equals to 0. Cool. Yeah, and this equals to plus infinity, and 1 minus 0, it is 1. 1 multiplied or times infinity, it equals to infinity. So cool. Now we resolve those limits. Now we are going to calculate the derivative. So x of the r star plus. So if we check that, we will calculate the derivative. So this is the equation, the next equation. As we said, we need to derivate the f. So we have the derivative of f, as we know in the rules, is the derivative of the expression of x, the square root of x minus 1 over 2 or a half of ln x squared. Cool. And the derivative of it. Cool. Sorry. Like this. Okay, cool. Now we have a function that is a little bit similar to the g of x. So we said g of x was x minus ln x. So to know that g of x, if we can get this 1 over 2 on dx, we will have a new expression. So it is the square root of x minus ln square root of x in the argument prime. So it refers to g of square root of x. It's not g of x, it's g of square root of x. Cool, yes, we will write it here, g of square root of x. So we are speaking about g, not the derivative of g now. In the derivative, so it becomes what? It becomes really the, now we can say it becomes to I forgot to write square, the derivative of the square of g of the square root of x. Cool. Yes, but we know that when we derivate a function squared, we write like 2 multiplied by the derivative in what is in the function. So derivative of square root of x is 1 over 2x. The 2 goes with the other one, square root of x. Yeah, we have here g of x of square root of x. Cool, yeah. Now we will have df, derivative of f equals to 1 over square root of x multiplied by g of square root of x. Cool. Now we have a cool expression that we can use to get the variations of our function. So we have 1 over 2 2 square root of x is always positive in the for each x of r star plus. Cool. Now we have the we have just the to use the variations of our g. So let's move on to draw our table of variations using the f prime. Cool. Yeah, the variations of f. So we don't have the 0 on the domain, so we exclude it, and we have here a 0 as we said. Here plus minus, I'll just check. Yes, we have it here, as you can see. It's a minus and the plus. Cool. Yeah. Now let's move on. So as we said, here we have a going down, here going up. For speaking about limits, we calculate it in them. So df of 1, what is df of 1? So if we substitute 1 in the expression of f here, 1 minus 1 over 2 ln of 1 is 0, 0. Okay, it's 1, it equals to 1. Cool. f of 1 is 1. Now I forgot the infinity. we have the limit on the infinity equals to of the infinity equals to infinity, as we said here, plus infinity, and the same thing for 0 as I remember. Let's check out, we have nothing to lose. So where is f of x? Okay, it's infinity as you can see here. Cool, yes. So let's move on to the next question. The next question tells us that we should yeah, I will write it here. So 3a, we must determine the what we call it, I don't know how we call it. We have first of all the limit of x when x goes to plus infinity equals to infinity plus infinity. Cool, yes. So first of all we will calculate the limits of x goes to infinity of f of x over x. We have this equals to the limit of x goes to plus infinity of square root of x minus 1 over 2 ln x squared over x. This equals to the limit of x when it goes to plus infinity. We don't calculate here the limits in the L'Hopital rule because we are not allowed to use it in this level of study. So speaking about the Moroccan students, yes, I don't know if it is universal, but I see some Americans doing it, so it's just allowed there, I think, in my opinion, but I'm not sure, not quite sure about it. So here we have the squared ln of x over square root of x multiplied by 2, my all this multiplied by minus, and the plus 1, and then factor of 2. Yes, factor of x. So we will just get rid of x, and we will have limits of in plus infinity of 1 minus ln x over 2 square root of x squared. You can here substitute x again, or just get this 1 over 2 on the x. So we will have the limits. I'm gonna write you that. So it's 1 minus the ln of square root of x over square root of x, and we will have squared. So this goes for 0, and we will have only 1. Donc just I spoke French again. Oh, sorry. So it goes to 1. Yeah, cool. You can write here 1, and then we will go to study again the limits of x goes when it goes to plus infinity of f of x minus 1 times x. We take the result that we got from f of x over x, this one, and we multiply it by x, and we subtract it from f of x, and we calculate the limits to get the answer. So minus x, let's calculate this. The limit of x, well, while x goes to plus infinity of, okay, f of x. Well, what is f? It is the square root of x minus 1 over 2 ln x, the whole squared minus x. So we can use a technique to a method. I'm just speaking English, French again, sorry. So we can use the factor with x, but when we will factor with x, we have here plus infinity, here we will have 1, and here we will have minus 1. That's where this will cause a problem. So we can use a good technique to, I said a good technique, method, yes. So it becomes the limit of x while x goes to plus infinity of, we will use the, I don't know how to call it, I don't have any idea, the identities, or I don't know. So square root of x minus 1 over 2 ln of x, and minus square root of x, same thing, square root of x minus 1 over 2 ln of x plus square root of x. Cool, yes. Now we will get rid of this square root, and then we will have the limits while x goes to plus infinity of minus 1 over 2 ln of x multiplies by 2 minus 2 square root of x minus 1 over 2 ln of x. Cool, yes, this is so great. Now we will have a good expression to yeah, we can use, but it's still indeterminated form. Here we have minus infinity plus infinity. It's indefined form, so we will just multiply with this in here. Cool, we will have limits in plus infinity and an x factor of minus 2, no, 2 will get off, so we get I don't know what you say. Okay, let's move on. Let's just move on. Yeah, we said then we will have a problem, but we can fix it. So the limit of x while x go to plus infinity of ln of x, ln of x times square root of x. Yeah, here we have 1 over 2, look, of ln square root of x. So we got a 1 of this 1 of 4 to the square root in the ln, as the property says. And here we put a minus 1 because we factorize with it. So this goes to 0 and this goes to infinity. Look at this, goes to infinity, and this multiplies by infinity. We don't forget the minus, it equals minus infinity. Cool, yes. So we got this. We say that the CF, or the curve of f, I don't know if you call it a curve or a, I don't know, but what I know, it is a parabolic, I don't know how to call it. We call it a branch parabolic. I don't know how to call it in English, so I don't have any idea. It is like this. I don't know how you call it. So I will just give the equation of the yeah, I don't know. I'll just write it. Okay, good, yeah. This. So let's just represent our function. No, wait, I will get the the ruler. Sorry about my English, just bad. I'm just trying to express good, yeah, good meaning, but it is a it's somehow hard for me, and I'm just trying to learn it. Yeah, good. Now are going to represent the our information. I'm sorry. So we got that the limits. Okay, we need to, or I can just use a software that do it. No, it's not this. So if we took a x over here, 1 is here, and the e and the I and the g of any it goes here, I think. Yeah, like this. So we take that and we go like this. Same thing for the other side. And then we have this we call it yeah. So cool. Yeah, we said in the infinity we have this we have a parabolic branch. I don't know how you call it, but I think it is like that. So, and in the zero we have plus infinity. We got it. In zero, yeah, you see here, it's plus infinity. That means that we have a asymptote. That's where's the variations? Yes, while it goes to 1, it changed the variations that as you can see here. It comes, we have a asymptote on this, on this, so it comes from here. I will draw it in another color. It comes from there. Bad at drawing. Sorry for that. Yeah. We said the f of 1 is 1, so it will go to the 1. So like this, and we will have like this, and this will continue like this, and we can turn back and see the okay, it goes to 1, the point 1 1. So we can just go and check it in the software and see if it is similar to the reality. I will be just right back in the website. As you can see here, it is similar of mine. So it is just like what I did. We can see our one. So it is a bit similar. It is not precise, but it seems like it. So I hope guys you liked the video. If so, just leave a like and subscribe. I just appreciate it, and thank you for watching, and peace out.